Hello, everybody. Welcome to today's Kubernetes training. My name is Matthew. I'm here with our senior solutions architect, Jason. We will be getting started in just a moment. We have a lot of people on the call, which is great. And I just want to wait another 30 seconds, see if anybody else joins, and then we'll get going. All right, let's get started. So welcome to today's Kubernetes training with Rancher Labs. Really excited to have everybody on today. We do these once a month, and we'll start doing them in April. We'll start having them a little more frequently. Just to introduce myself and my cohort on the line, my name is Matthew Scher. I'm the digital marketing manager with Rancher Labs. And if you have questions following this training, feel free to reach out to me. We will also be posting this training on YouTube as well, and you'll be getting a link to that in a follow-up email too. So if you need to get off or you want to share it with a friend, then or like check an answer to a question, then you'll be able to. And Jason will be going through the actual technical portion of the training.
Hello.
Hey, Jason. And so he has that all set up. I really quickly just want to go through the first couple slides, and then I'm going to hand it over to Jason. So again, our objectives today are to present with you an introduction to Kubernetes, hoping that you have a little bit of background in Rancher. If you don't, that's okay. I'm going to tell you how to get more familiar with Rancher as well. We're really going to try to keep the slides to a minimum. We have a lot of technical material to go through, and we really want to make time for your questions. So, this will be much more interactive. Like it says, demo and then demo some more. So this is live, and we'll be able to, mix and match things up for, who is on the line and what questions you have. And again, we will not leave until every question is answered. So on that note, if you do want to learn more about Rancher, we do assume that you have a basic understanding of some Docker concepts. Please don't let that be a reason not to ask questions, though. But our next training will be April 12th on Thursday. We actually have the day before on Wednesday, kind of a more in-depth Kubernetes. Well, we have an online meetup that's super popular. We have it once a month, and that one is managing workloads on Kubernetes with Rancher 2.0. So if this training is not enough, then that next one will be Wednesday, and then Rancher Basics will be on Thursday. Additional resources, you can always go to our docs. Again, this video will be recorded, so if you don't get this URL down right now, that's okay. But we have a pretty in-depth Kubernetes documentation on our website. In addition, our forums are awesome. We constantly have engineers, patrolling and answering questions and keeping the conversation moving. So if you have questions there, post them and they will get answered as well. So I think I might now turn it over to you, Jason. So you want to start here? Yeah, go for it.
All right, let me see if I can switch presenters here. Show my screen. All right. You guys see my screen here?
I can, sir.
Okay, great. Thank you. All right, so welcome to our training. Well, the topics that we're going to go over today, we're going to start with setting up Rancher, and then we're going to deploy a Kubernetes cluster. And then we're going to set up our kubectl for accessing that Kubernetes cluster and doing some actual Kubernetes stuff. And then we'll go over some topics like pods and services and deployments and ingresses, kind of the basics to get you started in Kubernetes. This training is meant to give you a good introduction to some of the Kubernetes concepts and patterns. It's not by any means a complete picture of all the things that Kubernetes can do. We hope that you have a little bit of knowledge about some basic Docker concepts, like you understand kind of what a container is and what an image is, because that'll make it that'll help you out along this so you can understand a lot easier. All right, so let's get to it. A little bit of full disclosure, I've prepared a few VMs and pre-pulled some of the required images ahead of time just to speed things up. But if you're interested in all the gory details, you can check out this Git repo, and I'll put it back up later under GitHub, under JGreat K8's training. And it has all the information of all the examples that we're doing, and also has some Terraform scripts for setting up an environment. So let's go ahead and get started. So I've set up one server VM and 3 agent VMs ahead of time. And let's talk about starting up Rancher server. Now you might notice that I've already got one started up ahead of time because it takes a few minutes for it to spin up. But if you were going to do this from scratch, you can either check out, again, the repo and the code examples in there. But really, it's as simple as doing this. You run docker, run -d. We're going to publish a port, 80. 8080, and then we're going to give it the image, Rancher server stable. And this will actually get you started with a kind of a POC quality demo environment. There is more instructions and more information about making that a full-fledged production environment. You'll have to check out our docs in order to do that. But you can see that I've already have one set up ahead of time. In addition, I've also set up a small HA proxy that has Let's Encrypt built in for SSL certificates. If you're interested in how that code looks, you can, again, look in the repo. There's an example of how that's set up. All right, so although I do have access control turned on, the very first thing you should do when you're presented with your new Rancher screen is turn on access control, and I'll kind of show you what that looks like. So we'll disable it. And you'll notice that there are several access control providers available in Rancher, Active Directory, GitHub, LDAP. In this case, we're going to use the local database and just set up a user for me. Put in my password. And we'll enable local authentication. All right, so now we have our authentication enabled. Let's go ahead and create an environment. That's the next thing we're going to do. So over here in this corner is the environments menu, and you'll see that a Rancher comes with one predefined, but we're going to go ahead and create a new one and show you what that process looks like. So we click on Manage Environments. We click on Add an Environment, and the host requirements for Rancher. We'll get into that in just a second. But so for adding an environment, we're going to do a Kubernetes environment. So I'm just going to call it K8, make it easy. You can see that there's many different providers, orchestration providers available in Rancher. But today's example is going to be all about Kubernetes. So that's the one we're going to select. And then if I had more users or groups, this is where I would add them to give them access to just this environment, because each environment is a separate security context on itself. Let's create that. We should now see in our menu that we have a default and now also our new K8 environment. I'm going to go ahead and select that one. And let's talk about adding some hosts. So we can see this is a Kubernetes environment, and we're waiting for hosts to come up. So let's talk a little bit about adding a Rancher agent host. So the host requirements are very simple.
Jason, can I just interrupt 1 second? Tennis is asking a good question, which I think it might be a good moment to answer, which is just what version of Rancher you're using.
The current stable version is 1.6.14. There is a slightly newer version, which is 1.6.15. I think that should go stable here very soon.
Awesome.
In addition, probably related on that note, Rancher 2.0, we're working on it right now. It is currently in an alpha state, so we don't recommend that you run that in, it's okay for looking at, it's okay for playing with, but we don't recommend you run that even in development environments at this point, because it is still unstable and not feature complete. But if you would like to go preview it, there are instructions on our website about installing that. It's pretty much as simple as what I did here. and you can go ahead and take a look at that and give us some feedback on what you think about the new interface. So, but that's outside the scope of what we're doing today. So, all right, back to where I was. We were adding some hosts. We need to add at least one host. It says, let's talk a little bit about hosts. So to add a host, there's a nice link here. The host requirements are very simple. Everything that we do is in containers. So all we need is a modern version of Linux and a compatible version of Docker. And then we can just start an agent container and we'll take it from there. So there are two main ways to add a host in Rancher. The first and very popular is to use the cloud providers. We give you the ability to launch VMs in your cloud provider of choice. You can just select one of these, like for example, Azure here. These available providers, you can fill in some credentials and give it a little bit of information about where you're launching it. Like for example, what region, the network information for it, what kind of image you want, any kind of security groups that might be required for that, storage options, things like that. And then you can also select one or more than one. You can select 10, as many as you want. And then Rancher will go ahead and actually talk to the cloud provider and start up VMs and install the Rancher agent, install Docker, install the Rancher agent, and get you up and running. So if I did it this way, in about 10 minutes, we'd have a functional Kubernetes environment. No one probably wants to stare at my screen for 10 minutes. So today we're going to use the custom method and make it happen a little bit faster. So the custom method is a very flexible method. Using the custom method is as simple as copying this Docker run command and pasting it onto the VMs that you want to run this on, that you want to join this environment. Now this Docker command here, you'll notice that there's a new unique URL in this, and this is unique to this environment. So what you can do is you can take it, if you have some existing orchestration, like maybe Terraform, or you're using Puppet or Chef, or Cloud Config, or whatever you might be using for orchestration. You can take this command and put it as like a finish up step in your current orchestration, and then you can add your host to Rancher very easily. So I'll kind of show you what that looks like. So I have my agent hosts. I have 3 of them here. So I'm going to copy and paste onto these hosts. And once I'm done pasting here. And what this is doing is it's running a Docker container, which is a Rancher agent. It's going to check back into Rancher. And then once this starts up and checks into Rancher, it's going to start scheduling out the various services that are required to get Kubernetes running in this environment. And if we switch over to our host screen, we should see that those three hosts have already checked in and are already starting to build. We can see that there are a lot of services involved when creating a Kubernetes environment. We're creating an overlay network. We're setting up health checks for services. And then we're actually creating Kubernetes services themselves, including, etcd, the kube API, the kubelets, the proxies, and then some add-ons. So while this is building out and getting ready, let's talk a little bit about Rancher's distribution of Kubernetes. So our distribution of Kubernetes is all 100% upstream Kubernetes. The only thing we've done is taken that upstream Kubernetes and we've put it in containers for easy deployment. We are CNCF, Cloud Native Computing Foundation certified. So it means that if it works in Kubernetes, it's going to work here, and vice versa. So we don't believe in vendor lock-in. So if you decide you want to take your ball and go home, you don't want to use Rancher anymore, that's okay. Any of your workloads that you're spinning up here, you can spin up in any kind of Kubernetes cluster. So you can take them to a different provider and use them there. So, we're not locking you into a particular vendor solution. We believe in openness of the environment. All right, so if that's the case, why would you use Rancher? Well, we do one-click upgrades to new versions of Kubernetes. So we're maintaining the version of Kubernetes for you and taking that work off your plate. We maintain the services and relaunch them in case of node failure. So if one of your nodes goes away and you're using our cloud providers, for example, we will reschedule another node and we'll go ahead and schedule those particular containers, those particular the kubelet and whatever else is running on that node onto the new node for you automatically. We do this 24 hours a day, 7 days a week, so you can get some sleep, because sleep is good. And in addition, we provide redundant etcd. We take care of the backups. They happen every 15 minutes of a 24-hour retention. And a big thing for if you're managing a whole lot of Kubernetes clusters is we do centralized authentication with your choice of providers. So when we set up our authentication earlier today, we had the option of setting up, for example, Active Directory, and we could have set up our cluster to authenticate with Active Directory, and you can give individual users or groups access to a cluster. And then when you need to, if those users leave the company or change jobs, and you need to revoke that access, so it's through your centralized tools instead of having to maintain something different and having to go out to each cluster and trying to figure that out. So, Kubernetes is just kind of the start of the story. So we also provide the Kubernetes dashboard, and I think these things should be ready to show you with a little bit of luck. So we provide the open source Kubernetes dashboard, so you can kind of get a GUI understanding of what your workloads might look like in Kubernetes. And we also provide a convenient CLI for doing ad hoc kubectl commands to get some information about what your environment looks like. So kubectl, we can do like get nodes, for example, and see what our nodes look like and what versions we're running. And we also provide a built-in tiller agent for Helm catalogs. We have some basic monitoring with Heapster and Grafana. And we also provide, should you want to manage your Kubernetes cluster, not through the web interface, we also have the ability to generate a config specific to your user. So these tokens and authentication credentials are specific to the user that's logged in. Again, so if you need to revoke that access, you revoke it through Rancher and you're good to go. All right, so let's set up our kubectl onto our laptop so we can have a little bit better management of our workflow here. So tilde kube config. Oops. You might tell that I am normally a Unix user and not a Windows user, so if I trip over a couple of those things, I apologize. So I already had a pre-existing one in here. I'm going to go ahead and delete that. You can combine these multiple configs into one configuration file if you want, but just for the ease of making this simple. Yes, please. Okay. Oh, of course that didn't work. Try that again. There we go. All right. So that is how we set up our kube config. And now at this point, since I have that configuration in here, I should be able to access my cluster from my desktop. kubectl get nodes. All right, great, we're connected. So now my default configuration points to this cluster. All right, let me pull up another screen. This makes some things a little bit more interesting. And let's go ahead and let's just jump in and start running things. So let's talk a little bit about kubectl. So you'll notice that there's a pattern to running kubectl. You start with kubectl, and then it's the action you want to do. For example, I did get, and then on the object you want to do, which was nodes above. Kubectl actually has other commands like describe and destroy and create. But we're going to use one of the helper commands called run. And if you'll notice when I'm typing this out, you'll notice that it looks a lot like Docker run. So if you've run anything in Docker, you'll be pretty familiar with this. This helper command run will create some of the lower level objects and abstractions that are required in Kubernetes to get things running. So let's take a look at how this works. So run, I'm going to give it a name. We're gonna run a game, and I'm going to specify an image. the public image, it lives out on Docker Hub 2048, and I'm going to give it a version 0.0.1. We're going to tell Kubernetes what port this is going to listen on. So port equals 80. And I think this game is actually going to be really popular. Replicas, and so we don't want to run just one copy of it. We're going to run 3 copies of this game to handle the load that I think is going to come in from this. So all right, we created a deployment game, and you can see that things are starting to pop up over here on the Rancher console. All right, so what did this do? Well, let's see. kubectl. We're going to do a get, and we're going to grab all the objects. All right. So let's talk about a little bit about what has been created here. First thing that that run actually does is it creates a deployment, which is shortened here to deploy, and called game. That deployment actually creates a replica set, and you'll see that it's also called game, but it also adds a replica set identifier to that. So it inherits, so in order to understand which objects are related to each other, you'll notice that the replica set, because it was created by the deployment, inherits the name game, and then it adds a unique identifier on that. And the same pattern goes down to our pods. So the replica set actually creates the pods that are running our workloads. So those are all called, they inherited the name game, they inherited the replica set ID, and then they also have a unique identifier. And we can see that, you know, from our status here that things are running and everything kind of looks good at the moment. All right, so what are these objects and what do they mean? So I kind of threw a lot at you right there. We're going to start from the bottom, which is the lowest level object, which is the pods, and we'll work our way back up the stack. So what are pods? Pods are the smallest unit that can be deployed in Kubernetes. You can actually just deploy a pod if you wanted to. That's really not what most people do. Most people actually want to deploy objects that manage their pods. Pods consist of one or more containers that are scheduled together on the same node. So pods can actually have more than one container in them. Interesting feature about pods is each pod is actually given only one unique IP address. This means that all the containers in a pod share that IP address, and that workloads in different containers in a pod can talk to each other over localhost. So you can imagine that could be useful in some cases. But to be honest, if this is kind of confusing, don't worry about it too much, because for the sake of this demo, all of our pods are going to have one container. So if you just think of a pod as a container, you'll be in good shape for this. So let's go ahead and let's show all of our pods. So let me click on that. kubectl get pods. And we can see this is all the pods that are running on our cluster right now. So you can see that each of them has one container, and that container is active and ready. You can see the status of the pods is running. You see that they haven't done any restarts, and you can see they're about 2 minutes old from this view. All right, but this is kind of a limited view. How do we get some more information about what is actually running on our pods? So let's introduce another command. It's kubectl. We're going to describe one of these pods. Oops. Come on. I actually need to, so we're going to describe, we want to describe a pod, and then we want to describe this particular pod. All right, let's talk about this output a little bit. So, you know, this describe has a lot more details about what is actually running in this pod. So we have the name, and we have what namespace it's running in. It tells us which node this pod is running on, which can be really useful information. The start time of the pod. Some labels around the pod that are used to basically associate objects to each other. Kubernetes also adds on a bunch of annotations, which are kind of like labels and metadata around the status of the pod, things that are going on with it. We can see the state, the IP address. We can see its parent object, which is the replica set. And then we actually get into what containers are running in here. And like I said earlier, pods could have more than one container, so there could be multiple entries here. But in this case, we have the image that we're running, which is that JGreat 2048 0.0.1. We have the port it's running on. We have the state, and some other information. But one of the most important things that this display shows is the events that have happened to this pod. And so if we were having trouble with our pods, they were like in a state of restarting or in an error state, this is the place I would go to get some information about what's going on. And right now we have a completely successful launch of these pods. So you'll notice that all of our event types are normal. But if we had had errors or warnings, they would be listed here as an error type. For example, if I had typoed the image name, instead of having a successfully pulled event, I would have an image not found event. So this is kind of the place where if you need to do some troubleshooting, you're like, oh, why are my workloads not working? This is where you would start off looking. So now that we've kind of described a pod and seen some of the details of a pod, what else can we do with it? Well, just like in Docker, we can run an exec against a pod and get a shell or run an arbitrary command. So kubectl exec, just like Docker, -it for interactive terminal, just like Docker. And we need the name of this pod that we want to run against. Oops. Come on, copy paste, please. There we go. So we got the name of the pod, and then we need the command we want to run. So this one has shell in it, so we're going to run shell. And now we have an interactive terminal on this pod. So I can look around, I can do ls, I could make modifications if I really wanted to, although normally you wouldn't actually make modifications to a running workload because as soon as that workload gets rescheduled, all those modifications go away. But it's a really great tool for troubleshooting and kind of seeing, maybe your application configuration of the pod. Okay, what other useful things can we do with a pod? So also like Docker, we can check the logs for a pod. So very similar command. kubectl logs. We can do a -f to follow. And then we just need the name of the pod that we want to follow. And then we can see here that we have a little bit of output from when this pod started. We're starting the game. It's got some credits on the person who created this version of the game and a little bit of information about the repo where it came from. So if you had like Apache or Nginx logs, it's probably where they'd be, things like that. So you can see, you can actually get the output of what your application's doing. Okay, so we've talked about pods. Let's talk about the object that creates pods. In this case, it's a replica set. So kubectl get replica set. If I spelled that correctly, great. Okay, so we can see we have a replica set. Its name is game. It's got a unique identifier. It gives us a little information about the pods that is scheduled, which is in this case, we desired 3 pods, replicas 3. We currently have 3 running and 3 are ready, so that's a really great place to be. And we can see that it's 7 minutes old. Okay, so why do we use a replica set and not just schedule some pods? Well, instead of imperatively describing, I want game pod 1 and I want game pod 2 and I want game pod 3, a replica set allows me to declare that I want game pods and make sure 3 of them are running at all times. This makes it really easy for when you want to say, well, I want game pods and now I want 10 of them running at all times. Just as a side note, there are several other objects that also schedule pods, but in different ways. There are daemon sets, there are scale sets, there are jobs. Those are some examples of other types of workloads that ways of scheduling pods that are available in Kubernetes. Now, we're not going to go into these in this training, but I just want to let you know that they're available so you can go ahead and check them out later. All right. Now here's kind of the sticky point in this. So in recent versions of Kubernetes, you don't actually interact directly with replica sets anymore. What you really interact with are deployments. So that's what run really does, is it creates a deployment object. And the purpose of a deployment object is to manage the release of new versions of your application. Kubernetes tracks the history of deployments and allows you the ability to undo a rollout if you need to. So let's take a look at our deployment. kubectl get deployment game. And you'll notice that the output for this deployment is very similar to what replica sets are, because deployments actually manage replica sets. So we can see we have our, our same thing with our pods. We can see how many are up to date and how many are available and the age of this. If you want to know a little bit more about your deployment, we can again kubectl use the describe command and deploy. So there are some shortcuts. One of them is deploy instead of, and PO. You might have seen those above when we listed all the objects. Instead of having to type out entirely deployment and then the name of the deployment. And you'll see some interesting information in here. You have the name of our deployment, what namespace it's in again. We have some labels. You'll notice that this run equals game is consistent across all basically the objects in our deployment and all the sub objects. And that's actually how it's really, what's the word I'm looking for? It is associating all the different objects together are actually through labels and through selector labels. So labels are very important to the way Kubernetes does things. In addition, some metadata, we see this annotations, deployment Kubernetes revision equals 1, which means we're actually on the first version that we've deployed of this deployment, so the first version of the software or configuration. And we get down here into the pod template, so you can see kind of what we're actually trying to deploy, which you'll notice is very similar to the information that was in the pods, which is the image and the port. If there were environment variables or mounts or volumes, they would be included here, and it also has some events. All right. So in order to show off, so let's say we want to now we have this version of our software, and we've made some updates to it. And now we need to deploy a new version. How do we go about doing that? Well, in order to show off how we do that, I really need to show off how we manage deployments, and first I need to introduce a new concept called manifests. So far I've shown you creating resources with some one-off commands, but the real strength of Kubernetes is that you can create resources in a declarative format. And to do this, you do this by creating and applying manifests. So every object in Kubernetes can be described with the YAML document. So let's take a look at the YAML document for our current deployment. So we do a git deploy deployment and game, and then instead of doing the standard git output, we're going to say we want to do -o, not 0, -o, and we're going to say do this as YAML. And this gives us out a YAML document that describes our current deployment. We can see here at the top the API version. And don't be worried when you see extensions, V1, Beta 1. Very Google of them to basically, beta is pretty much production, according to Google for some reason. So a lot of objects are still in use the beta API version, but they're perfectly safe and stable to use in production. Now, if you see one of these V1 Alpha 1, that's an object that you may consider not using in production. That's something that's still in development. So we also see what kind of object this is. This is a deployment. And these two fields are definitely going to be included in every single manifest, and they just might vary a little bit depending on what kind of object you're trying to interact with. In addition, we have some metadata around this object. We have the annotation that you saw earlier, which is some key value pairs. We have the creation date, what generation it is, versions. We have the labels that are attached to it. We have the name, we have the namespace, a unique identifier. And then we actually go down into what the spec for defining it's what it's deploying. So we have our replicas, 3 of them. We have our selector, which is how Kubernetes, the resources that this deployment is going to create. How does it figure out which resources it owns? That's through selector labels. And then we have our strategy. This is the default strategy, which is a rolling update. Then we have the template for actually creating the essentially replica set, and then the spec for the containers underneath that. And so we have our image here, our pull policy, you have which ports we have listed. This is also where you would list environment variables you might need to set, or volumes you might need to include, things like that that you would need to run your container. And then we have some, and also a part of this document is the status and condition of this object. Now we could take this object, just how it is, basically this YAML document, and we could save this. And we could do some minor editing and basically use it to deploy our deployment again, to apply our deployment again. But there's a little bit easier way to start off with base deployment objects, and that's a little bit cleaner, and I'll show you how to do that. So first thing I'm going to do is I'm actually going to delete the current deployment so we can kind of start over from scratch and you can see how this process works. So I'm going to introduce a new command, kubectl delete, if I can spell it correctly, delete deployment game. And this will actually, once we delete the deployment, it will go ahead and clean up any of its child objects by default. So it actually cleans up the replica set and any of the pods that we're running as part of that deployment. All right, so let's go ahead and create a manifest. And the easiest way I think to get started with this is we're actually going to use that run command later, but we're going to add a couple options to have it spit out a YAML file for us instead of actually creating the deployment. So I'm going to switch directories real quick here, just to keep me organized. And I'm going to scroll up here and find our run command. So we have our run command. Our game, we specified image, we specified ports, we specified replicas. In order to kind of put this out in a really simple YAML file, first thing I'm going to do is I'm going to give it the dry run option, which says, simulate that you're going to run, but don't actually create any of the objects. And then I'm going to say output of YAML, so it'll spit out a YAML document. And then we're going to redirect this output into a file. So game deployment YAML. So let's take a look at what this created. So cat game deployment. All right, so this is the YAML document that this run command with our -o YAML generated. And we can see if we do a kubectl get all, we can see that it actually didn't create any objects as part of this. It just created our document for us. So let's talk a little bit about this. This document is much simpler than the one we showed up here, which is essentially the same, but has a lot of metadata and status around it. So this is a much easier thing to understand and kind of update and keep in a repository. So all your definitions are code and version controlled. You're doing that right, or you should be. So let's go through this again. Again, we have our API version, we have our kind, we have the basic metadata required and labels required to get this running. You notice that we don't have a lot of information in the status, and we don't have a lot of like the annotations and things like that that were included as part of the running deployment, because they're not actually necessary to start up the deployment. All right, so in addition, we have our spec. We have our replicas defined. Again, we have our selector labels. We have our template for our down here for our replica set, which is going to create the containers. And we can see that the image will run and stuff like this. So now that we have this manifest, what do we do with it, right? So we have this file that defines our deployment. How do we apply this deployment? Well, Kubernetes makes that pretty simple. kubectl, we apply, we say -f, and we give it a file name. In this case, it is game-deployment. And this does essentially the same thing we did with the run command, except this does it in something that we can put into version control and check it into like a Git repo, for example. So we can save not only our code is in repos, but also our infrastructure definition is now in a repository. Okay, so now we have this. So kubectl get all and kubes. Let's take a look at our deployment. Get deployment game. Actually, I want to do describe. Sorry, I want to get details on it. So we can describe our deployment, and you notice it looks a lot similar to what we had before. But what you'll notice here is that we're running version 0.0.1. And the whole purpose of going back to showing you manifest and showing you how this works is to show you how easy it is to go ahead and roll out a new version of our application. So I have 0.0.2 that I'm ready to roll out. So what we're going to do is we're going to edit our manifest. So game manifest, maybe. Sorry, deployment. If I could spell correctly. Live demos are hard. All right, so we have our deployment manifest here, and we have our image version of 0.0.1, and let's up this to 0.0.2. Okay, I'm going to save our deployment, and now in order to deploy this new version, all I need to do is apply that document again. And any changes will get passed on to Kubernetes. So we apply this. We can see that new things are popping up over here in our window. And we can go ahead and describe our new deployment. We can see some actions happen here. When deployments happen, what is actually happening is a new replica set gets built, new pods get deployed, and then it scales down the old replica set. So what we have here is now we're running version 0.0.2. All right. So we did editing. We updated the deployment. So let's talk about how do we show the history of deployments. So Kubernetes keeps a running track of the history of deployments. This is so you can easily go and undo a deployment if, for example, our 0.0.2 app happened to have a bug that we only realized happened when we got to production. So let's take a look at the histories that are available. kubectl. Kubernetes stores these histories as rollouts. Rollout. We want to list a history of the deployment. Game. Okay, so we notice in this short version that we have two deployments. We have our first one and our second one. And so if you want to get details about which deployment is which, we could do revision equals 1. Spelled that correctly? Good, I did. We can see that game deployment revision 1 had the image of 0.0.1, and then revision 2 is our current one, and it has the image of 0.0.2. Okay, so let's say we did have that bug and we want to go back to the previous version. Well, Kubernetes makes that really simple. So we do a kubectl roll out, undo, deployment game. So by default, if you don't specify a revision you want to undo your deployment to roll out to a different existing version, it will go just to the previous one. If, for example, I had 3 revisions out and I wanted to go back to 1, I would also use the -- revision number to go back to version 1. And so at this point, if I do a kubectl describe our deployment, you notice we have more events, but we're back to our 0.0.1 version of our application. All right, so that kind of goes through the objects that run creates and how your basic workloads get set up. So, and this is the kind of the standard pattern to use when we're talking stateless applications, is to use a replica, use a deployment to create a replica set to create pods. So now that we have these pods and our service and our deployment, what do we do with it? How do we talk to how do other workloads in the cluster talk to our pods? So let's go ahead and kind of create an example of this. I'm going to create a new workload, which is just a shell that's going to run. So let's do this, kubectl Actually, apply
Hey,
dash F.
Jason,
Yes.
can I interrupt you for a second? Because there are several questions, and I think we
Okay.
might want to get to a few before you move on to a new topic. Is that okay?
Sure. That's perfectly
Okay,
fine.
great. So a quick one is just what CLI tool are you using right here?
The CLI tool I'm using, so this is actually CMDER Commander. It's available in the Chocolatey store for Windows. And then the CLI tool I'm using is actually kubectl, which is the standard one that comes with Kubernetes, or you install to interact with Kubernetes. But
Awesome. Okay, great. And then Daniel Anderson asks, can I create a location-aware desired amount of pods? In other words, ensure that two cloud regions are running equal amount of pods.
can I create a location aware? Can I assure that two cloud regions? Okay, so I'm not sure I exactly understand the question, but I will try to address this. I assume that you want different cloud locations to have different amount of pods, or if you want to have the same, you would just use the same manifest and apply it to do different clusters. Um, if you wanted to have, now I recommend, you can do a lot of things in Kubernetes. You can do an awful lot of things in Kubernetes. You can have a Kubernetes cluster that spans multiple regions. Um, but depending on your network latency and the situation around your networking, that may not be ideal because of the way the overlay network is going to spread across the two regions. If you were to do that, you could set up a deployment that has a selector for a node selector, basically. You would label your nodes with a particular thing, saying, US East 1 versus US West 1, right? You would basically create a label on each one of those nodes, and then you could have different deployments that would deploy those nodes, those different label selector labels. My recommendation, though, in most cases, unless you have a super fast network and you have like an OC48 between your data centers, which most people don't, would be to run a separate Kubernetes cluster in each region. Just because that keeps all the management and all the communication local to that region so that your Kubernetes cluster itself is responsive and you don't have issues if, for example, your VPN drops out between your regions. Network partitions can be a real pain. They're very unlikely within a region, but they can happen between cross-region communications. So, and in that strategy, you would actually just deploy the same manifest to each region, to each cluster. So, hope that helped.
Awesome. Okay, yeah, it's a big question, and we have. I'm just going to do one more quick one, I think,
Sure.
and then you can keep going. So this one is from Praveen, and he asks, when you run deployments with the command kubectl run game, where did you store this game object?
Where did I store the game object? The game object itself is not an object, and in that case, I'm doing a very imperative command. So the container, the image that I'm running when I did that. Let's go back up a little bit. Where's my run command? Okay, so the image that this is running is up in Docker Hub. This command doesn't actually have a manifest that's stored. That's why we talked about going into manifests and when we actually store an object locally. And then you can commit those to a Git repo. For example, when I showed, I have all the examples of these manifests actually available in this repo, so you can kind of check them out later on. So I hope that answers the question. If it doesn't, then I'm going to need some more details. So, respond back and give me some more details about what you're asking.
Awesome. Okay, cool. Thanks, Jason. Why don't you keep going? And there's a few more questions, but they'll take a little longer, so we can.
Okay. And yeah, like we said, we'll make sure we'll get to everybody's questions definitely by the end of the demo, or the end of the training. All right, so where was I? I was talking about, okay, now that we have a workload running, how do we talk? The first step is kind of talking to workloads within a cluster. How does that work? So I was going to go ahead and spin up a new new pod, a new deployment that has a shell for me to interact with. So kubectl apply -f /shell, and that was shell deployment. Okay. So you can see that that launched a new set of pods over here. And if I do a kubectl get all, there we go. We can now see that I have another deployment here and another replica set. In this case, it only created one. I don't know why kubectl get all actually displays these things twice. If anybody actually has a good answer for that, I would like to know. I wonder if it's just a bug. So we can see the replica set, and then we can see the pods for that. Okay. So let's go ahead and exec into this pod, and I'm actually going to do that in another screen here, just to another tab here, just to make this a little bit cleaner here. kubectl. We're going to run the exec. If I can spell. Exec. -it. Let me grab the pod name I want to exec into. There we go. All right, and then this one has a bash. And all right, so we're in this pod. It has a couple tools like curl installed in it, just to make talking between objects a little bit easier. All right, so if we go back over here to this screen real quick, we'll see that we have a bunch of pods and we have some deployments and stuff like that. And so I am in my shell and I want to now access my game pod. I want to hit its HTTP endpoint. So Kubernetes actually creates DNS objects for each one of these pods, but they have random names. Like these aren't predictable names that I can understand and I can create, standardized configurations for. But I can access them. So I could do a curl, and I can give it the pod name, and Kubernetes creates that DNS for me. And you can see I get back my HTML response from that pod. But really, we don't want to talk to pods directly. We want to load balance across pods because we have multiple of them. We have multiple pods as part of our replica set. And we want to be able to, when we add more replicas, we want to be able to pass the load in between. So statically talking to host name to single pod host names is just not a good pattern. It's just not going to work. So this is where we get into a service object and service discovery. So let's talk a little bit about that. So by default, everything in Kubernetes cluster can talk to each other over the cluster overlay network, but all the pods get random names and IP addresses like he showed. So how do we connect to these workloads? Well, this is with services. So services provide a couple of functions. They provide a consistent DNS endpoint and IP address for communicating between workloads internally to the cluster. And they also provide load balancing for the connection across the pods. So let's go ahead and show you our service manifest, and we'll apply that and see kind of how that works. So if I do cat game service manifest, and for now on, we're just going to be using the manifest to initiate our objects because that's obviously a better pattern. It's repeatable. We can, again, store our infrastructure configuration as code. We can version control it, all that good stuff. So, all right. So let's talk a little bit about what this object looks like. So services have been around for a long time, so they actually have a proper V1 API object version, which is kind of cool. We have the kind, we have the service, we have a little bit of metadata around this, and so we have our labels, our run, game, and our name equals game for metadata. And then we have our spec for our service. So services deal with ports. So we have a map of ports. In this case, we have we want our services listening on port 80 on protocol TCP, and it's targeting port 80 on the pods. And how does it figure out which pods to talk to? Well, again, we're using the selector labels. So any of the pods that have the run equals game label on them, it will actually load balance connections across any of those pods. So if you start goofing around with your selector labels, you can do some really interesting and probably not ideal things, just as a warning. But if you keep everything consistent, it works really well. So now that we, let's go ahead and apply the service. We apply the service just like we applied the deployment object. So we're just going to use kubectl apply. -f, and that was game-service. And let's take a look at this object now that we've applied it. Kube ctl get svc game. We could also type that out as full instead of just svc. We could have done it as service game. SVC is kind of the shortcut for that. And you can see that we have a game. It has a cluster type, the type of cluster IP. That's the default type. There are other kinds of types of services you can create. You'll have to check out the Kubernetes documentation for more information on that. We're not going to get into that in this particular training session. But the main purpose of a service is to enable service discovery from within the cluster. So let's go see what that kind of looks like. So now you saw before that we could curl that endpoint. Now actually that service has created a DNS endpoint called game that load balances across all of our pods. So when we curl game, we now see that we are still being directed to our pods. And that's a much more predictable name to be able to use. It doesn't have any of the random generated identifiers for the replica set and pod available. So that's the kind of thing that you could put into your application configuration or a config map or your Kubernetes manifest and say, you know, my database host name equals MySQL database, you know, if that's what you called it. And then give yourself really convenient names to do easy service discovery between your applications that run within your cluster. All right. So another concept Kubernetes has is namespaces, and namespaces are basically discrete service discovery domains. They're places where you can duplicate service and deployment names and things like that. So if you had multiple namespaces on your cluster and you wanted to talk between there is a fully qualified way to do that. So in order to fully qualify our service endpoint, it's game. It's the name of the name of the namespace, which in this case is default. And then it's SVC for service, and then it's cluster.local. And you can see with that fully qualified name that I was able to again hit my service endpoint, which load balanced to my my game application. All right, so that's how you can talk inside the cluster between workloads. So now that we've done that, how do we talk? How do clients outside of our cluster talk to workloads inside of our cluster? And the most common way to do that is with an ingress object. So let's take a look at that. Ingresses are layer 7 capable proxy services. Rancher comes with a built-in ingress. It's based upon HA proxy, but there are a whole bunch of other ingresses that are available to Kubernetes. One of the most popular is the Nginx ingress, and you can turn off the default Rancher ingress if you choose to do so, and install a different ingress. And you can also install actually multiple ingresses side by side with a little bit of advanced configuration. But that's a little bit more than what we're actually going to get into today, but I did want to let you know that that is a possibility. So let's take a look at our ingress object. So cat, our game -ingress. All right, so this is our ingress object. Again, we're back to a V1 beta API. In addition to the name of the ingress that we're creating, which is going to be called game, we have an annotation here that's Rancher specific, and we want to have a globally scheduled ingress, so that it'll actually do a ingress controller on every one of our worker nodes. And what this allows us to do, it allows us to use a couple of common patterns. One, we can either use DNS, and all we have to do is basically create a round robin record to any one of our worker nodes, and we'll be able to resolve, we should be able to connect to our game. And then from there, the ingress controller is going to talk back into our cluster and route traffic to the appropriate service. Or also very common is to put a dumb layer 4 load balancer in front of your worker nodes to just do load balance traffic across to the ingress controllers. So to kind of show off how this works, let's talk a little bit more about the rules. Now, when I said layer 7, this means that the ingress is capable of routing traffic based upon host names or based upon like HTTP paths. In this case, we're creating ingress that listens on game.jgreat.me. And then we also are having a path of the default path of slash of the root path. You could say if you had a different service that, for example, you were doing microservices for your application, you might have one service that feeds the default homepage, and you might have another service, for example, that's your API, so slash API path. And so you would create another ingress that had the definition of path slash API, and then you would point that at a different service backend versus the one that's your HTTP backend. But in this case, we're keeping it pretty simple, and we're saying that please route the traffic for, if you pass these rules, please route the traffic to the service name of game on port 80. So let's go ahead and apply this ingress. kubectl apply -f game ingress. And let's kind of take a look at what this did. So kubectl we want to get ingress game. And then I want a little bit more detail because it'll be truncated if I don't, and I'm going to say wide. Oh, and it's not quite ready yet. Still working on it. There we go. All right, so my ingress finished launching. We can see what IP addresses this ingress is listening on. You can see these public IP addresses for my nodes. And any traffic that comes in on port 80 on these public IP addresses will get routed, if it matches the host name, game.jgreat.me, it'll get routed back to our game service. So if I've done this correctly, this is where demos get crazy. I'm going to do game.jgreat.me, and we can see that we now have our 2048 game. So this is live on the internet. You're welcome to go connect to it and waste a whole bunch of your time. You're welcome for ruining the rest of your afternoon. And that's all the topics that I had planned to go over today. At this point, let's answer any questions you guys have and see if we can help in any way.
Awesome. Great job, Jason. Thanks so much. So we have quite a few questions. You might want to open the questions
okay.
slide if you're able to.
Open questions pane. All right. So please mention support for Docker containerization specification of 1.0. I'm not exactly sure what you mean there. Are you talking about Rancher 1.0? Or are you talking about this is from Peter. So if you can add some more information about that, that would be great. Let me see, what other questions are available? Questions, let's see. Instead of cloud providers, is there also a provider for Rancher for automating on-premise vSphere EXSI virtual machines? Yes, there is. And I can show you that real quick. Let's see here. If we go to hosts, we're at hosts, we add a host. And it doesn't look like it's enabled, but I can enable it real quick. Where is vSphere? So we have a whole bunch of providers that are available here. And we can turn on the vSphere provider, and it can kind of show you just a little bit about what that looks like. So you can see that there's a whole bunch of providers here available for all sorts of different clouds besides the ones that are just the ones that are enabled by default. We have OpenStack, we have Rackspace, we have Profit Bricks, a whole bunch of different things. We also have on-prem vSphere, which is pretty common. So let's go back to hosts. Let's see if we can see that now. All right, now we can see the vSphere provider is available. And you can see that there's some configuration. You're going to have credentials into the API. But if you have those credentials, then you can specify your images, your information just required to launch vSphere, and then launch it through us. And if you launch it through us, we can also, we'll manage the state of those VMs. And for example, if you say you wanted a quantity of 3, and for example, one of the vSphere hosts went down, we would go ahead and launch another VM for you if you have the capacity and reschedule workloads onto that VM to get your cluster back up to strength. So that's an advantage of using one of the available machine drivers for that. So, all right. Let's see, does one Rancher environment match one cluster, or can you have multiple clusters per environment? So it is a 1-to-1 ratio in Rancher. It is a one cluster manages one environment. It is one essentially security context for that environment. So you would assign users and or groups to that environment and give them access to that environment, and that environment is one cluster. Okay. Let's see here. Looks like that got answered. What else is on here? I'm reading through this. Previously stated using Hortonworks, HTTP, Ambry to Hadoop cluster for some data warehousing on a real-time acquisition system. I'm trying to learn about containerization and Docker. Started experimenting with Rancher. The bit I don't quite understand is how Ambry sets with Rancher server. I'm not familiar enough with Ambry for that particular question to answer that. I don't have any experience on that one. I'm sorry. I'd like to help a little bit more on that, but let me look. Let me read. There's a whole bunch of information in this question. Hang on a second. Let me see if there's something else I can answer in there. So you should be able to deploy Rancher server, deploy Ambry server in Docker container. How does that work with deploying cluster nodes in Docker? So if Ambry server is something to manage your Hadoop clusters, you could run that service in probably in a container in Rancher. And you may, if you're managing multiple Hadoop clusters, you may run that in a separate environment that's kind of a services environment that kind of has things that are used for running it, or you could run it in the same environment as your Hadoop cluster. There are some. I know that there are some community Helm catalogs for running Hadoop, which might be a good place to start when you start talking about wanting to run how to organize that. Might give you a good place to start with that. And I imagine the community also has some information about how to run that particular type of workload. So I'm sorry I wasn't that detailed on answering your question, but it's not something I have personal experience with. Okay, other questions. What's the difference between running Hadoop from Rancher server catalog and running it from Hadoop from Ambry? If you're running it out of the current Rancher server catalog, you're going to have to use the cattle. That's not a Kubernetes cluster technology. So there is going to be some differences there. So like again, if you want to look into that, you're probably going to want to look at the community available. There's a large community available Helm catalog that is supported by Kubernetes, and they probably have a Hadoop example in there for you. I'm going to move on from those specific questions. All right, 2-container PHP app MySQL instance get inside the same pod. How do I get the endpoint for the DB inside the app as a parameter? My personal opinion is you should not run those workloads in the same pod. You should run a different deployment for your MySQL for your and then for your PHP apps. Why? Because you may want to update your MySQL app database separately from your PHP applications, and having separate manifests for that makes it really easy to decouple those two things because they're not necessarily related. So that was this question. Okay, other questions? We answered that one. Let's see, how does the storage using content of one pod updated, same will be replaced on remaining pods? trying to understand the question. So there are a couple patterns to using storage on pods. The main pattern that you want to, if you need persistent storage in pods, you should look at the persistent volumes and persistent volume claims in Kubernetes. Those are the objects you use to interact with storage. And the pattern that it kind of follows is, this is a little bit more of an advanced thing, so I'm not gonna get too deep into this right now, but I'll give you kind of a hint on where to start. So the pattern starts is that you define a storage class for the server. This class may be like named NFS for NFS storage, or if you're using like EC2 backed EBS storage, you might call it EBS. And then what you do is you create a persistent volume claim object as part of your catalog, part of your manifest set that you're going to use to deploy your application. As you notice that when I deployed my application, I use separate manifest files. Usually that's kind of the pattern, one for each object, each type of object. And so you're going to create a persistent volume claim, and you'll either use the default for the cluster storage, or you will go ahead and set up, or you'll say use a specific type, like for example, I want to use NFS. So you'll define that in your persistent volume claim, and then when you deploy that, it will go ahead and kind of like how deployments kind of create replicas and pods, your persistent volume claim will go ahead and create a persistent volume for you, and then depending on how you define that life cycle, it'll either be a persistent storage that'll stick around forever, or it might get reclaimed when you're done with those pods. So there's a lot of details on that. I hope that helps with your storage question. All right, next question is, hi, are these 3 Kubernetes master nodes? How do you specify which nodes are master, which nodes are worker nodes in Rancher? Okay, that's a good question. This talks a little bit about strategy. So by default, we don't do a separate data and orchestration plane from the worker planes. The way that works in Rancher, and I can kind of show you the concept here, is if I go into my stacks, I can go into my Kubernetes configuration. And you can preset this up ahead of time. You don't have to do this after the fact. But you can set, instead of plain isolation, which in the documents it describes this a little bit better. Plain isolation says, do I want my worker nodes to be the same nodes that my etcd and my orchestration tools are on? So you can say required in here. And if you say required, then Rancher is going to look for, you're going to have to label your nodes specifically. So you'll create a couple nodes that have a label of etcd equals true. You'll have a couple of nodes with orchestration equals true, and you'll have a couple of nodes for your workers that say compute equals true. And that can be defined when you launch your hosts. If I go back over here, I say add a host. For example, I do the custom. You can add a label to this particular set of hosts, and you can say, I want these to be etcd equals true, or sorry, etcd not equals true, but etcd is true. And then this label will get applied to the nodes, and then only etcd resources will get applied there if you have that plain isolation turned on. So I hope that answers that question. Yeah, in a just kind of as a side note, in a more production instance, just kind of playing around, it's easy to have all those things combined. But in a more production instance, it is a best practice to separate your data and orchestration nodes from your worker nodes, so that if your workers get carried away, they don't crush your the actual orchestration tools that are required to maintain the cluster. Okay, next question. We have been working with Rancher and cattle cluster management. Great, I'm a big fan. We now have our service catalog described by Docker Compose and Rancher Compose files. May I be able to reuse those with K8 cluster within Rancher? So this is a little bit of a complicated question. In Rancher 2.0, we do have plans to allow basically a translation layer for that Docker Compose and Rancher Compose to take those objects and turn them into Kubernetes objects. Depending on how deep you've gone and customized that, your mileage may vary, to be honest. things like there are just some major differences between things like volume drivers in Rancher Cattle and the way Kubernetes does volume drivers. So there may be some modifications you're going to have to make to get these objects to work the way you want them to in Kubernetes. So the answer is we hope so, but there may be some work you need to do to redesign it if you want to go to Kubernetes style of orchestration, because they are pretty significantly different technologies. Okay, so that was that question. Hi again. Which version of Kubernetes is deployed? So the version of Kubernetes that is currently deployed in this was 1.8.10. The latest version of Rancher 1.6, 1.6.15 does use the 1.9 series, makes that available. Can you enable RBAC? You can enable RBAC. And the way you do that is by defining that in, again, we go back to the Kubernetes cluster settings. You can see that we're running 1.8.10 right now. And down here in the settings is enable Kubernetes RBAC. And by default, we turn that off because it's simpler. But if you want to start doing things like restricting access to various namespaces and things like that, that is totally a thing we can do. You can turn on RBAC controls, and then you can go and there are some, under our Kubernetes documentation, there are some examples on how to apply, for example, like Active Directory groups or other service providers that we provide, authentication providers that we provide into the RBAC controls for your cluster. So, all right. That was the RBAC question. Okay, can you restrict network access between pods? By default, no. If you start getting crazy with RBAC controls, that may be a possibility, but all the pods within the cluster are on the same network. So, but in Rancher 2.0, that is something that we're adding in, is we're actually adding in discrete networks for what we're calling, or a concept we're calling projects, which are a group of namespaces that are wrapped by RBAC controls. So you can assign users and permissions directly to basically a group of namespaces, and each one of those groups of namespaces, each one of those projects will have a discrete network space in order to make that a little bit more of a security context. Again, this is going to be something that's available in Rancher 2.0, so stay tuned for a preview of how that's going to work. Okay, next question. We're currently using Cattle with an older version of Rancher. We can use host labels to deploy stacks of containers to certain hosts. Is that possible Kubernetes? And can we limit pods to X hosts and said pod? Yes, you can. Kubernetes absolutely has the concept of labeling your hosts and then doing selector labels for those objects. So you can say, like, I have my database hosts, for example, and I only want my database workloads to be over on those hosts. That is something you can absolutely do in Kubernetes. Not going to get into the nitty-gritty details of that, but you can start taking a look at that. Look for information about using selector labels in your pod definitions. Okay. What would happen if if the cluster detaches from Rancher server? The short answer is that is a whole lot of nothing. So Rancher's management interface is separate from the Kubernetes control plane, and that's actually a really good thing. So that means Kubernetes itself will continue running and the workloads will continue running. So the only thing that you lose is if you're using, which is probably why you're using Rancher, is that we proxy authentication through the Rancher server, so that although your workloads will continue to run, you probably won't have direct access to your clusters, so you won't be able to modify those workloads or do no deployments while you're getting your Rancher server back up. But that doesn't mean you're going to have a production outage. That doesn't mean your development environments are still going to be available, all those things. It's just your management of those that are going to be impacted. So, all right, hope that answers that question. Okay, how did you create the YAML files, especially for your game ingress? Okay, so there's no shortcut for creating ingress YAML files. You do kind of have to look at the Kubernetes documentation, they have some examples to start out with that you can copy and paste from. So it is possible through, there's a shortcut command called expose that does services. You can use that in the same way that we did run with a -- dry run and a -o YAML options to create the services YAML. But again, you start kind of developing patterns for that, and copying and pasting and working from those when you're developing new sets of application manifests. And again, what you can do is actually you can create the object. You can actually export from, well, it's like that's a chicken and egg problem, right? I'm like, you can create the object. Oh, wait, you need a manifest to create an ingress object. So yeah, I mean, really what you're doing is you're kind of looking at the documentation and working from there. Okay, what's your recommendation? Hybrid cloud plus on-prem rancher-based deployments for production. Okay, I think I went over this a little bit earlier with one of the questions, which was, my recommendation is if you're doing a hybrid cloud, that's perfectly fine. Rancher 1.6 supports creating Kubernetes clusters in your cloud provider of choice. You can go to Azure, but these are EC2 VMs, for example. You might have some of those, and you might have some on-prem. My recommendation is not to mix those within the same cluster. My recommendation is you're going to run a separate cluster in EC2 and you're going to run a separate cluster on-prem, so that if your communication, like your VPN goes down, somebody trips over the fiber in your neighborhood, whatever happens, that you get a network interruption there, you don't have a lot of problems then with like a split brain cluster. They should really be local to your cluster, should really be local to the region that it's in. So my recommendation is, yes, absolutely you can do the same things, and then you just duplicate deployments between them, and then use some other services to do maybe like a global load balancing or something like that, if you're doing a hybrid. Now in Rancher 2.0, we are also going to support creating your Kubernetes clusters with things like Azure's Kubernetes Service, AKS, EKS for Amazon, and also GKE clusters. So you can actually utilize those services instead of running VMs if you choose. And then we'll manage those through the Rancher interface. So again, stay tuned. Check out when we get to our Rancher 2.0 training that we're going to do later on next month. Let's see. How do you persist data? We kind of talked about that a little bit. I kind of gave you the hints about some of the objects. It's a little bit more than we want to get to in this training. But like I said earlier, you're kind of looking at creating a storage class object that's at the cluster level to define what kind of storage you have available for the cluster, and then setting one of those as default. And then you're looking at using a persistent volume claim that's part of your application manifest to define that volume, and then you're mapping that persistent volume claim in your deployment manifest when you start defining your containers and volumes that are attached there. So that's kind of the set of objects that you're kind of looking at in order to do persistent data. But persistent data is one of the harder things. That's why we're not going through it in the, it's a much longer training, and we're not going through it in this basic training. So how do you perform rolling updates of Rancher itself? Let's see here. So okay, so the Rancher server, if you save, if you're doing a production grade server, you are either using an external database, MySQL database, maybe something like Amazon's, gosh, I'm blanking on the name of it, RDS service for the database, so that you have backups and replication. Or at very least, you are saving the volume that is presented in a Rancher container, and that information on how to set that up is available in our documentation, which conveniently, if you're using Rancher, is linked here, or it's docs.rancher.com. And if you save that data, basically what you do is you delete the old container, again, save the data, and then you spin up the new container at the new version. So I would go over to my server, and instead of using the stable, I might be running, if you're doing it in production, you probably want to tie it down to a particular version. So it'd be like v 1.6.14 is the current version I'm running. And then when I wanted to go to 1.15, I would stop this container, and I would delete this container, and I would spin up a 1.15 container. And then if you configured it the same to point to the same database, it's going to go ahead and do the database migrations that are required, and then bring up Rancher with your at the new version. So that's how you update the Rancher server. At that point, you may be prompted with quite a few options to update things like the versions of Kubernetes that you're running. And those options will show up in the infrastructure stacks. You'll see see how it says update available. When there's an update for it, you'll see a new version available. It'll be a nice yellow button that lets you say that there's an upgrade available, and it'll tell you what version of the stack is available. So, and then you'll go through, and on your time, you'll go ahead and update these Kubernetes objects. And if you scheduled out your workloads correctly, there should be no interruption in service. Obviously, things that might be singletons, which they may have an interruption in service depending on what kind of upgrade has happened. But most of those container workloads should be perfectly fine. Test it out in dev. Okay. Let's see, on-prem, persist data, we did rolling updates. Are you dropping support of cattle in 2.0? The short answer is yes. We're not going to continue to maintain the cattle orchestration. We are adding in support, like I said earlier, for bringing your catalogs and your Docker Compose and Rancher Compose manifests over to 2.0, and then we're going to do a translation layer to spin those up as Kubernetes objects. Is there going to be an upgrade path? There isn't going to be an upgrade path. That's going to be defined in version 2.1. It'll come out later this summer. Okay. Is Rancher a single pane of glass? Looks like yes. Technically, the answer is yes. You can run one Rancher server and manage multiple clusters in multiple locations with your one Rancher server and use it as basically a single pane of glass. But that guy left, so he doesn't get his. I shouldn't have answered his question. All right. Would it be possible to migrate environments to existing Rancher from 2.0? That is a question and patterns we're going to address in 2.1. So that is a stay tuned for more details on that. Okay, when to use cattle or Kubernetes, that depends on what you want, what your workloads look like, and which kind of workloads that you want to, what kind of manifests you want to work in. But ideally, you're probably going to want to use Kubernetes. It seems to be the way the industry goes these days. Where does Rancher store its database? Check out our documentation on that. I think it's like varlib MySQL inside the container, but don't quote me on that. Let's see here. Question regarding persistent volumes, data, and backups. Again, that's beyond the scope of this question here on persistent volumes, databases, and backups. That's beyond the scope of this training. Again, I kind of gave you some pointers around earlier about that, about storage classes and persistent volume claims. Let's see, we answered the launch of 2.0 question. After adding Active Directory authentication, the container kubeds dashboard didn't start. That is probably a deeper question. I'm not going to address that here. That's some troubleshooting question. There's lots of reasons why that wouldn't start. Adding Active Directory authentication wouldn't be one of those reasons. So that's going to have to go a little bit deeper, which was after adding Active Directory, he had some trouble with starting kubedns and dashboard. Okay, question about detached state. You said you lose the possibility to authenticate. Does this count when authentication method, every authentication method? What about certificate authentication? So the way we do authentication with Rancher to Kubernetes is you actually can, if we look at the kubectl, you'll notice that the server we're pointing at is actually the Rancher server. We're not pointing directly at clusters. And that way we can manage the Kubernetes, the access into your Kubernetes clusters. So everything is authenticated through the Rancher server. And then we are basically proxying those requests back onto, after we've verified that you're a user and you have access to those resources, we then forward that request back onto Kubernetes. All right, I think that's it. I think we covered everything.
Wow, amazing job, Jason. So good. So why don't I take back control of the
Sounds good.
presentation? Can you go ahead and change it to me as the presenter?
Let me do this. Change presenter. There we go. Okay, back to you.
Okay, great. So just to close out here, we do have a lot of slides. And a lot of people did ask for slides and recording, and so everybody is really clear. We will be sending out a recording of this call, of this session afterwards. So look for that in your email. There'll be a link most likely to the slides as well. And just some additional resources for you all. The Slack channel is just awesome. There's a ton of activity on there. Slack.rancher.io is free to join, and then you can check out the Kubernetes channel and continue to ask your questions there. So again, thank you so much. There's more information we also have in our ebook, Deploying and Scaling Kubernetes with Rancher. So that goes even more in depth. It's pretty awesome. Vishal and Girish are actually in the process of writing an update for 2.0, but this one it continues to work for 1.6. And I think that's all we've got. So again, look for your email. The resources there, and if you do need any help from us, you can reach out to me at matthew@rancher.com or see us on Slack. So thanks a lot, everybody. I'm going to go ahead and end the presentation there. And thanks, Jason. Great job.
All right, thank you. Goodbye.
Bye.